Good morning, good afternoon, good evening. Hello, welcome to the first episode of the Sounding Board. What is the Sounding Board, I hear you ask? Great question to start the day, and that's exactly what it's all about. It's all about questions. It's a community-driven program born out of my simple desire to lend a helping hand to the vast landscape of AWS Web Services community. The Sounding Board is ultimately the aim is very straightforward. It's to provide a supportive space where builders and students can seek guidance based upon AWS services, share ideas, but ultimately troubleshoot challenges they're having as well with anything that's AWS based. It's community driven, so the idea is that we're bringing community experts and lend a helping hand with that knowledge that we have. It's very much based upon the same concept as rubber duck debugging. That's right, I said rubber duck debugging. Yep, this thing. It's a common concept with developers that when they get stuck with their code or a concept, they'll often talk to an inanimate object in order to try and straighten the ideas out in their head and make certain sense of problems that happen. Rubber duck debugging. The ideas behind this particular show are very much based upon the community as well. There's a way you can get involved. If you look just here on this side, we've got a QR code. You can scan that QR code and it will take you to a form you can fill out and you can ask any idea you want. And if your idea makes it to air, this is what happens. Today, we're going to be talking about going serverless. In my original form that I sent out to the community via LinkedIn, we had a common thread, and that was people wanted to learn serverless. Specifically, Hemanta reached out, said he wants to understand serverless at quite a broad topic. So what we're going to be doing is the next 3 episodes, we're going to be talking about different concepts of serverless. So episode 1, today, we're going to be talking about serverless containers. Next episode, in about 2 weeks' time, we'll be talking about serverless functions, how to write serverless applications without the EC2s behind it, without containers, without worrying about any of that infrastructure behind it. And then in week 3, we'll be looking at serverless databases, how to still store your data and not have to manage a server behind that as well. So that's the next 3 episodes coming up. How do you get involved? As I mentioned earlier, you could either click on this link just here, which is the QR code, scan that will take you to the form, or you can do this link down here, which will be in the description later as well, to again fill out the form with an expression of your interest to be involved. So let's start today. As I mentioned, we're going to be talking about containers, serverless containers specifically, how to take an application and turn it into a serverless container. What's a container? Great question. A container is ultimately a lightweight, standalone software package that includes everything you need to run your application without worrying about things like operating systems, security patches. All you have to worry about is your code inside of the container. All the runtimes, etc., are also packaged in that as well. And all you worry about is your code. Unlike traditional virtual machines, there's no patching, there's no security patches specifically with the operating system, and it is all very much allowed to run itself in its own little isolated environment. Effectively, containers are the cool kids of the software world. Don't tell the serverless function people that, though. Containers don't care where they're running. They can run on your laptop, or specifically, they can run on the cloud as well. And that's what we're going to be doing today. We're going to be creating a container, and we are going to be then launching it into AWS. Our legacy app that we're going to be testing today, that we're going to be playing with today, is a website. And this is one thing that I can show you. I can show you what my legacy app looks like. Just like many legacy apps, it is very simple in this case, just to make sure that we're not going to be causing any confusion. Our legacy app is a website. It could be any website. There you go. It's on the screen right there. And that's it. That's exactly it. It's a website. It could be a website which is PHP or Node based. It could be an API, but in this case, it's just a website. It's hosted on EC2. At the moment, it's behind a load balancer. It doesn't have to be, or it could just be on my laptop for now. But ultimately, that is just a simple application that we're going to be looking at today. Now, let's just have a quick look at the setup of what I've got in Amazon already. So what you'll see here is I have the EC2, Amazon Web Services console open already. And I'm just going to zoom in so you can see that there. And I've got an EC2 running with my web server. That web server, that EC2 instance is nothing more than just I've dropped my website onto it. I don't want to patch it, and I don't want to mess around with EC2s running all the time because they are hard to run sometimes. I don't want to patch them. I don't want to maintain a Linux operating system. I just want to run my website or my web application. So on this particular EC2 instance, we find that Apache is installed as well. I can show you that. And inside of the website, inside of the main web directory of Apache, we've got the 3 files that make up my simple web app. We also have a VPC set up already in this particular account, so we're not going to cover the creation of a VPC. And we also have a load balancer involved as well here as well. That's to service the traffic as well. Our new app needs to look a bit different, and our new app needs to look the same in the web browser, but our new application is going to also utilize that same load balancer, and we're also going to be creating the Docker container from scratch using a Docker file. We're going to create something called a task definition, and we're also going to then run that inside of an ECS cluster, Elastic Container Service. How does that look from an architectural perspective? So I've got my whiteboard here. So ultimately, we've got our user people, people that use the application, and they are going to be coming into the load balancer first. Excuse my writing. I write like a 4-year-old, as you can see on the screen. So our customers, our users are going to come in to the load balancer. From that, we're then going to find that that load balancer is going to pass the traffic on to, at the moment, what would be an EC2 instance, and that would be the end of it. Instead, we're going to remove that EC2 instance, and we're going to be putting in place instead an ECS cluster. That's an Elastic Container Service cluster. Elastic Container Services is the AWS service that manages anything that's container-based within AWS. Elastic Container Services can manage Docker containers on EC2. It can also manage them serverless using Fargate, and it can also do EKS as well, Kubernetes. Today, we're going to be concentrating on ECS Fargate. Within that cluster, you're going to find that we also have a service inside of that cluster. And that's a container service. So then the traffic from our friends here will come straight through, all the way through to the service. A ECS service is a collection of tasks, container tasks. And so those tasks are launched to provide the service that is within your container. The service, the ECS service, will launch as many tasks as it needs within your specifications to scale that web service. So you go from having just a single EC2 instance, which is unscalable at that point, to having a service which can scale in and out based upon user needs, meaning that you have more flexibility, which means you can start with smaller instances, save a bit of money, or make it more flexible. So what we're going to do is we're going to talk less theory and more about doing. So we're going to start off in the console, and then we're going to go and try and do this in CloudFormation a little bit later with a little bit of help from our GenAI friends. So the first thing I'm going to do with you is to try and create the Docker file first. Now, a Docker file is ultimately a specification that shows us and tells Docker what it is that you want to do, how to create the Docker image. So I'm going to open up another window now, and what you'll see here is got VS Code open, and at the moment it's open in my website. My website is quite simple. It's just a HTML file and a couple of pictures. But what we're going to do now is we're going to look through a Docker file that we need. So I've created this ahead of time just to help you guys out. And what we'll see is how simple this is. So because I want to be creating a website in this case, I'm going to be using an image from the public ECR gallery. ECR stands for Elastic Container Repository. And a container repository is where Docker images are stored. So we're going to be starting with the Apache ECR public image. And that's the first line in my file here. I've specified from, and then my image that I want to use as my base image. And so I'm going to be using the latest version of Apache. Now, this little bit in the middle here just specifies what type of container we're building. So we could have a ARM64 container, which would mean it runs on a ARM chipset, or if we don't specify that, it will just run on our Intel chipsets. That's a conversation for another day. So we're going to create this Docker file. The first thing, as I said, is the from line, and then the second part of this is the copy line. What the copy line here is doing is it's taking a copy of my website and it's placing it into the default location for Apache websites. So here it will copy the background, JPEG, the index HTML, and the poster PNG into this folder, ready to host it immediately. That's it. That's as simple as this gets. There are other commands that you can run inside of a Docker file to make it more powerful, such as specifying work DRs, running certain commands, executing files, even specifying an entry point file, which will specify how your Docker is going to run once it's built. In this case, we're going to be utilizing the default from the Apache image in order to be able to launch our web server. So let's go and put this together in the console. Now I have, let's go into the AWS console. And let's start putting this together as an image instead. So the first thing we need to make sure we've got is our own repo. You'll see I've tested this earlier, but we're going to create it live today. So I'm going to give it a name. And then with the default settings here, we should be okay. There's lots of settings here you can enable. We're not going to go into those today. I want to keep this really simple. But there's lots of things you can do with security, such as encryption or security scanning on the repo as well. So that's our repo created right there. We now need to build our image and then put it into the repo. Now, luckily for us, AWS make this really, really easy. What they do is they provide you with the relevant commands you need to push your Docker image up to the repo. Just that simple. And that makes life a lot easier for everybody. So we're just going to follow these instructions now and follow through. So I'm going to open up another window for you and just switch out to a command prompt. Lots of screen switching, I know. It'll be worth it in the end. So you will see here, we've got the Docker file that we created. So I'm now just going to follow those prompts that AWS have provided us. So the first one, if I've done this correctly, is just to log in to the repo. It says login succeeded. We're going to build our image. It built successfully. And then we're going to give it a tag. Why do we give it a tag? It's so we can differentiate the image from other images. You could either give it a unique name or you can just call it latest, and then you'll always have the latest version. And then we're going to push that Docker image into the repo we've just created now. What you'll see there is it's pushing all the different bits of the image up to the repo ready for us in different layers. And that's it. That's uploaded. It's that quick. So if we then go back to our repo now, our ECR repo, to see if that has appeared. And we'll see. I'm just going to close that window there and then refresh. We have our image, and it was pushed up literally minutes ago. So now we can use that image, that ECR image, as part of an ECS cluster, an ECS service, or an ECS task. So let's go and create ourselves a Elastic Container Service cluster. So if we click on Create Cluster, and again, we'll call it Live Demo Docker Example. We're going to make sure this is a serverless infrastructure type using Fargate. Make sure that's ticked there. And then create. Now, this is going to do a few things in the background. And one of the really clever things it does here is it tries to build not only the cluster in the background, it's also building the CloudFormation specification, which we'll come to later, in the background as well. So one of the things that we need to do once we've built the cluster is we need to then create our task definition. The task definition is similar to a Docker file in some respects. It is to a ECS service what a Docker file is to a Docker container. And that is ultimately the specification of how your Docker container is going to run inside of the cloud. So we're just waiting for that last bit to finish. This is the risk with live demos at the end of the day. Sometimes it can be quick, sometimes it can be slow. And there we go. We've got a green light. That's good to go. And just to make sure we can view our cluster, our cluster is there. So let's go and create our task definition now. So if we go and click on task definitions on the left, and then click on create task definition, we're going to create a new one. And again, there's going to be a lot of settings in here, and we're just going to do the basics that we need for today. So we're going to call this live demo task def. And again, it's going to be a Fargate container. And now the one important thing that I will mention here is that in our Docker file, we had that command that said -- platform, and it said ARM64. This is where that's relevant. So if we click on this drop-down box and change that to ARM64 to match, that means it will run on an ARM container. Now, that's just my preference for processor at the time, but if you've not used that platform tag, you could stick with x86 64, but ARM64 is my personal choice, and that's what I've chosen. And so I've got to make sure I reflect that inside the task definition as well. There's other settings in here, such as the task size, how much CPU do you want to give it, how much memory do you want to give it. We're just going to stick with the defaults for now. That seems fairly common sense for a small web server that would be accepting traffic. And then we just need to make sure that the task role is selected as well. That is the IAM permissions that allow the task to run inside of AWS. We now go through the container specification. And one of the things that is important here is that we use the URL here from our repo that we made earlier. So I'm just going to go and get the URL for our container, which is here, the URI, and we copy and paste that into just here. Give it a name. I'm just going to call it website. I know, I like to be creative. And the rest of this should be okay. The container port is going to run port 80. That's not a problem. And we're going to allow it to use the default settings for resource allocation. There's all sorts of settings in here that you can play with. If your application is a PHP application and it has environment variables behind it, you could add them here as well. You can also specify the logging mechanisms that you want to use as well. In this case, I'm going to go with the default CloudWatch mechanism. Seems fairly common sense at the time. And then we are going to go and press create. And that's our task definition created. So now we've got a task definition. We have a Docker container. We have a cluster. Let's go and create our service now. So we go back to clusters and then live demo Docker example. You'll find you've got a couple of tabs down here. Services is the one that we want. However, just to go over this as well, if you want to create a single task, you can do that in the task window. Tasks that are running out of services will also appear here as well. And then you've got infrastructure settings, metrics for monitoring, and any scheduled tasks that you want to run. So for example, if your website had a scheduled task to send emails to a certain number of customers once a week or once a day, or it's got to collect the trash and dispose of the trash. They're what we used to call cron jobs in Linux servers. You could do those here using a Fargate container as a scheduled task instead. But back to services, we're going to click on create service. And again, there's a lot of common sense defaults that are provided to you by AWS already. For example, the provider strategy should be fine, or we can go through launch type instead. I'm just going to go launch type. And it's going to be a Fargate launch type. It's going to be a service because that's what we want to make. We want to make a service. And then we pick our task definition from here. Pick the latest one. If you were to make multiple revisions of your task definition, you could change it here as well. Use an older version if you want to compare two versions of your product. I'm going to give it a name. And then we tell it how many tasks we'd like it to create for us. So in this case, we're going to be creating two tasks. I want to make sure that I've got enough capacity for the people to get onto my website, for example. We're going to go into networking now. And networking, as you notice here, compared to other settings, is not optional. So we're going to go into networking, and we're going to select our VPC that would have already been created for us. And I'm just going to place, even though it's selected subnets for me, I'm just going to place it inside of the private subnets only. This was a VPC that was created using the VPC wizard within the VPC console, and it automatically creates you a certain number of public and private subnets now. So I'm just going to use those private ones. I'm using Sydney, so AP Southeast 2. I'm also going to then select my security groups. So I want to get rid of this default one. I'm going to select the same security group that is in use for my web server at the moment. If we go back to the EC2 console, we'll see that it's currently using this security group here. So I'm going to be using the same one. If it's doing the same thing, it might as well do the same thing. However, I'm not going to give it a public IP address. I don't want to present this to the outside world. And then there's the option for load balancing. This is optional, but we are using a load balancer in the EC2 example, so we want to reflect that in our container. So we're going to choose application load balancer, and the container that we've just started up, website that we called it very creatively. And we're going to use an existing load balancer. We're going to use the existing listener that's already on the load balancer as well. And we're going to create a new target group. Let's create a new target group for ECS so that we're not causing any confusions there. We want it to accept all traffic and not specific paths. Ultimately, it's going to be replacing the other target group long term. And that's about it for the creation of a service. So I'm now going to click create. Again, oh, I missed a setting, sorry. Just the evaluation order of that particular rule. Now, it should be the only rule in place, so it doesn't matter what order we put that in. It just allows us to order rules. Now I'm going to click create, and as long as the demo gods are with us, that should go through and create the service. In the meantime, I'm going to go back over to my load balancer. And I'm going to remove a rule. And I'm going to remove this rule here, the default rule. Well, you can't remove the default rule. So I'm going to be editing it. I'm also going to make sure that any traffic that's coming into this load balancer goes straight to the container rather than going to the web server. And then that way, we know that the container is taking all the traffic and not the EC2 instance. It's still deploying at the moment, which makes me nervous because now we're going to find out if this worked or if I made a mistake. It deployed successfully. So the other way of testing this to make sure that it came up okay is to go back to our load balancer in the browser, and I'm going to refresh this page and hold my breath. Okay, I got an error. That can happen at times, and that's what we're here for. We're also here to ensure that we know how to debug these things. Our container is running, and it's still booting maybe, but we also make sure that we've got our 2 tasks running as well. So by all rights, that should be working. What we'll do now is we'll go into just double check that that's working okay. If not, that's okay. We can debug that later. There you go. It worked. I just typed the load balancer name wrong. So it's working, and it's now working through the container instead, rather than the web server. Just to confirm that, I'm even going to shut down the EC2 instance now, because we don't need the EC2 instance anymore. And it's still working. Perfect. Whew, that was my moment over. How do you do this in CloudFormation? And that's an absolutely great question to ask, because sometimes you want to do this in such a way that is repeatable long term, but also if you wanted to move it to another AWS account, or if you wanted to do a disaster recovery, then you could do it through infrastructure as code rather than doing it through having to click in the console, because again, there's lots of things to remember in the console. Just remembering all those steps to go through for a simple application, sometimes it can be a little bit stressful in a disaster recovery situation. Now, I'm going to go through, and with a little bit of luck, Code Whisperer is going to help me. My GenAI friend, Code Whisperer, is going to help me build out the relevant CloudFormation templates to create the service and the task. We've already got our repo. We've already got our container. So we're just going to try and create the service and the task in CloudFormation. Is anyone else as scared as I am at this point? Let's hope that the demo gods are on our side still. I'm going to share my VS Code. And there we go. There's a folder here called live demo that I'm going to work within. And so we're going to create a file here called ecs.yaml. Now, I'm already logged into Code Whisperer. Why am I using Code Whisperer to do this, I hear you ask? Because no good demo these days can go anywhere without necessarily having GenAI mentioned in it. We are in 2024, and the tools are here to help us. So I'm using Code Whisperer, so I'm going to actually tell Code Whisperer what I want to do, and hopefully it can help us out. So ECS service to here's one I created earlier, apparently. CloudFormation template to create a ECS service for a given task definition. See, yep, sure, let's go with that. And let's see if Code Whisperer is going to allow us to do what we want to do. Apparently not. So we're going to give it a little head start here and just give it the description and the template version. As you can see, I did create this in a test earlier. And that's better. So it's already starting to give me the parameters that I would probably need. So I'm going to need a cluster name. I'm going to need an ECS service name. I'm going to need a task definition name, a load balancer name, and a target group name. That sounds fair to me. Now we're going to ask you for resources. And it's already suggesting that our ECS service, our target group, and our load balancer listener is already there. All right, so ECS service. We need to give it a cluster name. So the cluster name, we'll set that up when we launch this. The task definition name will give that when we do that as well. And then the load balancer is also offering us the relevant configurations. Now, this is where we work out, did Code Whisperer do this right or not? And so the saving grace here is that it can make mistakes, but at the same time, that's what we're here for. We're here to learn and to run through this. ECS service target group and load balancer listener. There's one thing missing. Or is there? I don't know. Let's see if we can test that. Now, one of the things that you'll notice if you go into the CloudFormation console as well is that AWS created the ECS CloudFormation templates for you as well. So it's always a little cheat instead to go and look at these ECS console live demo Docker examples and have a look at the templates here as well. So that's an example of when sometimes Code Whisperer goes wrong and doesn't quite provide you the right demo at the right time. But ultimately, you can also then grab the ECS CloudFormation templates from here as well. As I said, live demos don't always go right, but what we have achieved so far here is we've created our website in the console using a container, migrated it from EC2 to a container instead. So ultimately a success at that point, not so much with the CloudFormation template, but that's always a risk with live demos. Cool. So how could we improve this application? There's many things that you can do with web applications. You could use custom domains. We could add an SSL certificate to it. These are all things that weren't considered in this example. We could also use things like pipelines, products such as code pipeline, code deploy, or the relevant pipeline tools to be able to deploy your code automatically into your container instead. So all you have to worry about is writing your HTML code, deploying it to GitHub, and then it will automatically build your container. You could also then have further infrastructure as code, just like we tried to create with Code Whisperer to create the load balancer as well, all the VPC to make repeating that example a lot easier in the future. So that was ultimately us trying to convert an EC2 instance into a container. What we learned today was how to create a serverless app, how to implement it in code, and how to use Elastic Container Service. I'm going to thank you today for tuning in. If you tuned in live, thank you very much. Appreciate it. If you're watching this recorded, then don't judge me too much. But make sure that you tune in for the next episode, which I can guarantee you will be a lot more fun because we'll be using serverless functions. Thank you to the contributor for today's idea, Hamenta, who came in through LinkedIn on the form. If you also want to get involved, then you can click on this QR code just here, or you can use the Get Involved link just down there as well. Watch out for the next episode. Next episode is going to be serverless functions, as I keep mentioning. It will be on the 8th of May. Follow on LinkedIn or on the YouTube channel for when that update is going to happen. And if you've got any feedback, don't be too brutal. This was episode 1, and things are always going to go wrong with a live demo. But I can guarantee you we're here to learn together. And hopefully, if you've got an idea, something you want to discuss, something you want to talk about, bring to air, then let me know. QR code over there or link down below. And remember, if you've got any issues, have you tried explaining it to a rubber duck? See you later. Bye.